From devices to cars, lithium-ion batteries power almost everything in our modern world. When it comes to recycling lithium-ion batteries, Li-Cycle is at the forefront of innovation. We're speaking with Li-Cycle Vice President Alan Ferguson on the podcast from Recycle My Electronics, A Welcome Diversion, with EPRA President and CEO Cliff Hacking.
Welcome to A Welcome Diversion. I'm Cliff Hacking, President and CEO of EPRA, Electronic Products Recycling Association, and we're happy today to have as my guest Alan Ferguson. Alan is with Li-Cycle and is responsible for recycling lithium-ion batteries, and we're looking forward to a terrific conversation today. For us, batteries are an important part of electronics. EPRA is responsible for electronic recycling in provinces across the country. And the result of that is many of the electronics that we deal with have batteries in them. And most of the batteries these days are lithium batteries. And so we want to know a little bit more about those batteries and how they get recycled and what happens with them at their end of life. But before we jump into all of that, let's jump back in the time frame a little bit to where you and I first met. So about a dozen years ago, you and I came across each other. And from that time, have had quite an interaction versus, I guess, other people that we might have known. We certainly have known a number of different organizations, and you're now with Li-Cycle, having previously been with a processor. And I know your background, which I'd like to hear a little bit about, has engineering in it, because I can see you're wearing the iron ring.
Yes, that's right. I don't do this much anymore, but I still do wear the ring. Yes, so I'm Alan Ferguson. I am an electrical engineer, so I've spent my entire career working around electrical and electronics products, and now with Li-Cycle. So again, always around electronics and electronics products.
Yeah, that's fantastic. And in all that time, we've stayed in touch, and the result of all of that, through the evolution of different regulations in provinces, we've now grown to see the lithium-ion battery processing really take flight. Now, you as Li-Cycle have developed quite a number of facilities, and so started out quite small. Give us a little bit of history of how Li-Cycle started and the great progression that we're seeing. Because as you say, there is a lot of lithium batteries being brought into the marketplace these days at the expense of other technologies. And the result is that those chemistries aren't getting used as much, and so there's more and more lithium to be recycled at the end of the day.
Yeah, absolutely. So our company is only 5 years old. So we definitely don't think of ourselves as a startup anymore, but we still think of ourselves as a young entrepreneurial company. Our first facility that went into operation was in Kingston, Ontario. And our second facility that went into operation was in Rochester, New York. And we've just launched our third facility in Arizona, in the Phoenix suburbs of Gilbert and Mesa. And we have many plans to launch more facilities in the upcoming months. By the middle of the year, we'll have our first facility in Tuscaloosa, Alabama. And we've also announced facilities in Ohio and our first two in Europe, in Norway and Germany. So all the facilities I've mentioned so far are the sites where we recycle the batteries. Our company actually does two things. We recycle the batteries, and then we take the outputs that we produce from recycling the batteries and send the lithium, nickel, cobalt, manganese, graphite, etc., to another facility that we are currently building in Rochester, New York, that will be a wet chemical hydrometallurgical refinery. And that's just a fancy way of saying we're going to take the intermediate materials and produce battery-grade chemicals that can be used to manufacture new lithium-ion batteries. And so that's how we provide the full closed-loop solution for our clients. And so our future deployment will include both these recycling facilities that we call spokes and these refineries that we call hubs. And our plan over the next 5 and 10 years is to continue to build more of each and to be a truly global company, having these types of facilities in North America, of course,
Sure.
in Europe, and also in the Asia-Pacific region.
That's fantastic. And in all that time, we've stayed in touch, and the result of all of that, through the evolution of different regulations in provinces, we've now grown to see the lithium-ion battery processing really take flight. And that has been something that's been relatively recent. Talk to us a little bit about what that looks like in terms of when it started and when we started to see some processing in this space.
Yeah, so if you go back in time, based on my days as a processor, there were many, many different types of batteries, and there still are. There's alkaline, there's nickel metal hydride, nickel cadmium, absolite. We can go on and on. But what's been happening in the last 5 years or so is that more and more of the applications that are using batteries are moving towards lithium-ion batteries. So we're clearly seeing its market share increase at the expense of some of the other batteries. And there's a number of reasons for that. It can be energy density, it can be power density, it can be the time it takes to recharge the batteries. There's a whole host of reasons why this transition is happening. But the bottom line is there's going to be more and more lithium-ion batteries in the future. And it's not just within electronics and power tools and things like that. Obviously, the transition to electric vehicles is a key driver there. As well, we're moving more to wind energy and solar energy. And in those situations, there's often batteries involved because you need the power, not necessarily when the sun is shining or when the wind is blowing. So you capture the energy, store it in batteries, and then release it to the network when it's required.
That's fantastic. So tell me a little bit more about the rechargeable versus the non-rechargeable batteries. How do you see that kind of split?
So I would say in the consumer space, we still see a lot of single-use batteries or primary batteries or non-rechargeable batteries being used. And a lot of the applications can either use a primary battery or a rechargeable battery. So it's really up to the consumer which one they choose to put in the device in many cases. But we, again, see more and more of the applications moving to the rechargeable batteries.
Yes. Now, when I think about recycling of batteries, I know that one of the things in the electronics industry that we're responsible for is ensuring that we get a high percentage yield in terms of a recovery rate from what comes back to us. And so if you look in the electronics space, you'll find that, it's mid to high 90s in terms of what we're able to recover and put into some kind of a recycling mode. The few things that we can't recover are things like a fiber board that might be in an old speaker, a big large speaker that would sit there because there isn't really a lot of use for that particle board and you can't really recycle that and do anything with it. But most everything else we're able to recycle and get back to another use, whether that's the plastics or whether it's the batteries themselves or the metal that comes out of it. In lots of cases, you got ferrous and non-ferrous metals that are coming out and then some gold and silver and those kinds of things. In your space with respect to batteries, what does that recovery rate look like for batteries? So when you get a lithium-ion battery back, how much of that are you able to capture?
So I'll answer that two ways. Traditionally, if you look at lithium-ion battery recycling, I would estimate that about 40% of the material in the battery was recovered. Once we have rolled out our spoke and hub solution, we'll be recovering up to 95% of the material. And so why are we able to achieve that kind of an improvement? There's a couple of reasons. The first is that we don't burn the batteries. Many of the traditional solutions out there take the battery and thermally treat it or burn it.
Yes.
And so all the plastics are burned off. Mm-hmm. A lot of the other materials are burned off as well. And then what's recovered would go to a nickel smelter or maybe a copper smelter or maybe a cobalt smelter. But they don't care about the lithium. They don't care about the manganese. They don't care about all the other materials. They're just really, they're from the traditional mining industry, they're focused on just one or two of the materials.
Sure.
Where our solution and our hub is going to recover 9 different outputs. So we're going to recover the plastics. We're going to recover all the copper, all the aluminum, all the ferrous that you mentioned. We'll recover the lithium, the nickel, the cobalt, the manganese. So all the different elements that are contained within the various types of lithium-ion batteries will be recovered.
That's a great story. And when I think about that, you just have to think about where we are from a mining perspective. One of the statistics that we have used in our space with respect to electronics is that there's about a 10 times factor with respect to recovering materials versus mining virgin materials, meaning that it would cost 10 times more to go and dig things out of the earth and produce them for manufacturing than it would to recover those items when we get electronics back. So if you think about aluminum or gold or copper or those kinds of things, recovering those is much more efficient and better for the environment. And of course, some of these things have limited supply in the world. That is a terrific story from your perspective because you're going to then be able to recover all of those metals and probably be doing an even better job than some of the smelters that are currently in place.
Yeah, absolutely. We've had people conduct studies for us, And for example, if you just look at the water usage that's required in our solution versus traditional mining is less than 5% of what is required. Significant carbon dioxide reductions, sulfur oxide, nitrogen oxide, all these emissions that come along with the traditional mining are significantly reduced with our solution.
Yes.
And even just going back to what we mentioned a few minutes ago, the traditional approach to thermally treating the batteries, we have a much lower carbon footprint compared to those solutions as well.
Yes. That's terrific. And for a company that's only 5 years old, this is just great progress and really is a story that we want people to hear. I mean, one of the reasons we do these podcasts is so that people get a sense of the value that's coming out of recycling electronics. It's so that they will bring back those cell phones or those computers that have lithium-ion batteries in them, and then we can take them and ultimately get them back to a facility like yours that's going to be able to process them.
Yeah, absolutely. And I'd just like to add that everybody thinks of lithium-ion batteries being in their laptop or in their tablet or in their cell phone, but they're in everything now. They're in your gaming controller. They're in your remote control. They're in your portable camera. They're in your portable display device. Anything that can be portable likely has a lithium-ion battery in it now. And so they're just in so many products, and it's important that they all get back, and so they're managed properly through the different processors associated with recycled myoelectronics. Because if they end up in the blue box stream or they end up in the general waste stream, that's a big risk to society because people don't always know that there are these lithium-ion batteries in those devices. So it is important that the batteries do make it back to you.
Yes.
So critical.
Yeah. It is, and one of the things that we find, and I don't know what your experience has been, but from a safety perspective, it's also important that those batteries get sent back as well, because there is a greater likelihood of contamination with things like if you take a nickel cadmium battery, you don't want those leaking out and getting into the landfill. So when people throw out their Duracell or their Ever Ready battery, you don't want those just leaking into the water tables. So those things are important for us to capture as well.
You mentioned before that lithium isn't necessarily bad for the environment like cadmium might be, but a lot of lithium-ion batteries have either cobalt or nickel, and cobalt dust and nickel dust is very detrimental to human beings. So how they're processed is very important as well, whether it's with your processors or whether it's at our facilities. For example, we take in all the lithium-ion batteries and we actually shred them in a submerged solution, in an aqueous submerged solution. So there's no dust in the air. And that solution is a special solution that absorbs all the energy that's released when the batteries are shredded. So that's how we do it safely and responsibly. That's how we make sure there's no nickel dust, no cobalt dust, no graphite dust in the air, impacting the health and safety of our employees.
And the environment at large as well.
Absolutely.
Yes. No, that's terrific. That really is. So when you think about the future of batteries and where things are going, you touched on a little bit earlier the fact that there is more and more in terms of growth in the lithium-ion space. But beyond that, what do you see happening with this space?
So, the growth is a key factor. And, if you look at the demand and the supply curves, over the last few years and what we see for the next few years, they're fairly consistent. But we do see the potential for 3 to 5, we're not sure exactly when, but at some point in the future that the demand will outstrip the supply. And so it's critical that we are recovering all of these battery-grade materials. So that's one of the trends that we're watching very closely. It's also a key part of our business proposition at our company because we can close the loop and take batteries and then provide back battery-grade materials to our customers. A lot of our conversations with battery OEMs, consumer electronics OEMs, EV OEMs, is all about that. If they send us their batteries, they want their nickel back, they want their cobalt back, they want their lithium back. So that's a key part of our conversation with many of our customers.
And that closed loop manufacturing is something that I would think, if you think about just the way companies are profiling themselves these days, and environmental, social governance, and all of the trends that are going on with people wanting to make sure that they're investing in companies and buying products from responsible companies, those things have to be something that are really good omens for your organization, because companies are going to want to deal with someone that can take that material and get the kind of returns that you're talking about and get the products back.
Yeah, absolutely. We see that a lot. It used to be, even a few years ago, a lot of the RFPs that would come out would be, what is your price?
Yes.
What are you either going to charge me or what are you going to pay me? Now it's, yeah, we want to know about that, but we want to know about your recovery rates. We want to know about all of your emissions. We want to know, are you using green power or not? Like, all these other considerations are often, add up to a greater portion of the decision that a company's making than just strictly the price.
Yes. And as you see the change with respect to vehicles, so there's a number of companies who have made announcements that by 2025 or 2030 or 2050, there's various dates out there for various organizations, that they will turn completely to electric vehicles. Those batteries are going to be lithium-ion batteries as well, are they not?
Yes, depending on what evolution and innovation happens over the next number of years, but right now the path is for lithium-ion batteries. They will be, and if they're not lithium-ion batteries, they would likely be some variant of what we call a lithium-ion battery today. So, for example, one of the things that people are talking about is a solid-state lithium-ion battery. So today, the fire risk that comes with a battery is based on that liquid electrolyte that exists within the battery, and that electrolyte allows the charge to move back and forth, so you can discharge and recharge the battery. And it's also that liquid electrolyte that causes the fire risk with the batteries. The idea of moving towards solid-state batteries is that you no longer have that liquid electrolyte. And also the anode of the battery, instead of being typically graphite or silicon today, will also become lithium. So increased demand for lithium in these future batteries as well. But it will also allow you to make the battery smaller, or for the same size, pack in more energy so that you can get the extra distance with your electric vehicle, or your cell phone will stay charged longer, things like that. But it will also mean that you don't have the same fire risk that you have today, which is critical for the battery. So it's really bringing the two big factors, the fire safety risk and the range anxiety with electric vehicles. It solves both of those issues if this technology truly comes into fruition.
Yeah, I mean, one of the drawbacks that I think most people think about with electric vehicles is the driving distance and the charging stations, of course. But the driving distance is one of the limitations these days. As they start to improve that, it will make a dramatic difference. What percentage of the lithium-ion batteries do you think would come from electric vehicles today versus other sources? It's got to be smaller, I would think, at the moment, compared to where we expect it to go.
So if we go back 2 years, I would say 50% of our input feed came from consumer batteries, and 50% came from electric vehicles and energy storage and these other more industrial applications. I guess an electric vehicle isn't industrial, but it's a much larger battery than a portable consumer battery. And today, this is likely about 80%, and the consumer batteries are about 20%. Okay. So we are seeing that increase both from electric vehicles, also battery manufacturing. In addition to the end-of-life batteries, we work with battery manufacturers, and we'll recycle the scrap that they produce in their manufacturing operations. So that's a significant portion of our material as well, as is the energy storage. As people are decommissioning some of the early energy storage systems, there's a lot of lithium-ion batteries coming to us from that application as well.
And the energy storage is related to things like solar panels and wind farms, those kinds of things?
Right. Exactly.
And there's a great change going on right now with respect to that, with people seeing more and more wind farms, more and more solar panels. The recycling of solar panels is a whole other topic for another day,
That's
probably.
Right. That's right.
They're a difficult thing to recycle.
Absolutely.
And in fact, here in Canada, Alberta is the first province that has said they're going to attempt to recycle them, although to my knowledge, the only place that is doing any kind of a credible job with this is in France right now. So we'll have to see how all that evolves. But it's not just the batteries that store the energy, but it's also the vehicle that's collecting it right now that we're going to have to think about recycling as well.
That's right.
Beyond that, how do you collect batteries from other sources? So I understand the electronics field, but there's a lot of other sources as you've described. So how do you get your hands on those?
Yeah, so I would say if we look at the electric vehicle space right now, we work a lot with either the dealerships themselves or the head office in a country to receive those batteries. Okay. We will also work with the battery manufacturers. So if you look at the energy storage market segment, sometimes we might work with the actual operator of the solar farm or the wind farm. Sometimes we'll work with the battery company who supplied the batteries to them. Sometimes we'll work with a company that specializes in decommissioning services, and they come in and just manage the whole decommissioning project. Sometimes there's the engineering company that designed it in the first place, and they take ownership of it. So there's many streams, many customers, many verticals for us. And so, it's important that we understand how this all works and that we're talking to all of the right people.
I mean, from, I guess, my perspective with electronics, it's pretty easy because they go to the processor deconstructs them, the batteries come out, they need to find a home for the battery. Oh, here's Alan, let's send them to life cycle, and the battery gets processed and life is good. For the other batteries, not quite as simple a process, not quite as streamlined and organized an approach, I would think.
That's right, especially as a lot of these new applications are just evolving right now. We're all trying to figure it out and understand how it's going to work, not just how is it working today, but how is it going to work in the future. Yes. And there's a lot of regulation coming, not just Canada, the US, Europe, everywhere in the world. Everybody's looking at what are we going to do with these lithium-ion batteries? Do we need to change the fire code? Do we need to change other regulations to deal with how people store, how they track lithium-ion batteries in the workplace? So we follow all of that regulation or potential regulation very closely as well.
I would think that, so typically Europe has led with that kind of regulation. If I think about the EU, they have been at the forefront of recycling. It's certainly in the electronics industry, they were the first to come out with programs to say you must recycle your electronics. It then migrated to Canada, and we're well ahead of the US in terms of that. In fact, at the moment, there are only 25 of the states that have any kind of electronic recycling programs. In Canada, we've got quite a diverse set of regulated obligations, where in British Columbia, it's everything with a battery and a plug. And the East Coast pretty much mirrors that. We're very close in terms of PEI in Nova Scotia, having that same kind of profile with an environmental bent in terms of making sure that things are dealt with in an environmentally responsible fashion. And the U.S., falling far behind really in many regards there. So do you find that the US is different than Canada in terms of its recycling rate and what you're seeing coming back?
With consumer batteries, yes. Not as much with the electric vehicle batteries and the energy storage batteries. And the reason is because of this potential lack of supply of critical battery materials in the future. So the battery manufacturers and the EV OEMs are very focused on knowing where their batteries are so they can get them back, so they can recover the lithium, nickel, and cobalt for the future. So there's a huge focus on that. We've actually seen some of the EV OEMs starting to throw models out there like, I'll sell you a car, but I still own the battery. And the battery is something I'm going to lease to you, and I will swap it out at my choice, 4 years, 5 years, 6 years, when I want. So they really want to take control and ownership of those critical battery materials.
When you think about where lithium comes from, I'm not aware of certainly all of the places that it is mined. I believe there's some in Saskatchewan.
Yes, you're right.
Where we can mine currently lithium. Are there other places, and is it something that's going to be in short supply soon?
Yes, based on those projections that you were mentioning before about the EV manufacturers saying by 2030, 2040, the percentage of their sales that they want to be electric, we project that there will be these gaps with not just lithium, but with cobalt and nickel as well. And so that is a big factor. Other areas of the world that have a lot of lithium would be South America. There's an area that basically borders 3 South American countries that has a lot of lithium. There are lithium deposits in Europe as well. But it gets into, there's a lot of political issues that go with it as well. There was a very famous situation in Serbia, and there was a company looking to set up a mine there, and it was shut down by the government. So will that resource get mined in the future? Possibly. But, there's a lot of geopolitical issues that come along with it as well.
And are there particular dangers in mining lithium? Is it trickier than mining gold? And we know that there are some difficulties with gold in terms of arsenic and things that can be damaging to the environment.
Yeah, that's not my area of specialty, so I don't want to get into it too much. But I think any active large-scale mining, has its tailing ponds and has its issues, and there's different ways that lithium can be found, spodumene and different types, so they require different technologies to recover it. But yeah, there are issues, and that's one of the reasons why, there's always opposition whenever somebody wants to bring large-scale mining of lithium into production. And, on one hand, we want to see it because it's part of decarbonizing the economy through electrification, but yes, we also understand that in the local economy where the mining is going to occur, there are going to be people with those opinions, and they need to be respected and taken into consideration when these projects are brought forward.
But all of that just buttresses the good that Li-Cycle can do. If you think about whether it's reducing the mining impact, whether it's recovering the resources that we have, the energy factor involved with those things, the imprint that we're having on the environment, whether it's carbon discharge or whether it's just the entire environmental concern, all of those reasons are good reasons to recycle, which is what we're about here. Whether it's the work that I do or the work that you're doing, we're both trying to get us to a place where more recycling takes place, less gets put into landfill or other sources that don't get recovered, and cause us as a society to be both more responsible and ultimately more successful, because if you run out of those kinds of materials, it's going to impact our ability to be able to survive and function the way we'd like to. It certainly will degrade lifestyle.
Yeah, absolutely. And, if we go back 12 years ago when we first met, a lot of the focus at that point in time was keeping the nasty things out of the landfill so they don't contaminate the landfill.
Yes.
And that's still very important. But clearly the focus on recovering critical materials, whether it's battery materials or other materials, is now, also front and center in terms of why we need to recycle. Absolutely.
Alan, thank you very much for coming today. Really appreciate it.
It's my pleasure to be here, Cliff. Thank you.
Well, today has been a great conversation with Alan Ferguson of Li-Cycle, and I have enjoyed very much bringing you this podcast, Welcome Diversion. We look forward to your comments. Anything that you have, please send to recyclemyelectronics.ca. We'd be pleased to hear from you, and we look forward to speaking to you again soon.
Welcome Diversion is brought to you by EPRA Recycle My Electronics. To find the location nearest you, visit recyclemyelectronics.ca. The future is in your hands. Don't let it go to waste.